This section is entitled Linear Regression. In the last section, we talked about how two variables might in fact have a linear correlation. So this heading or section is entitled Linear Regression. Now, since two variables might have a linear correlation, then now let me be clear what that means. If you have data that look like this, there's some line that goes through it. And I want to find the equation of that line. Now, make believe this line isn't here yet. If I draw some points around that, if I have some points, some data points like this, there might be a line that goes through it, like the line I just drew. And what we want to do is find the equation of that line. And then we could approximate things from that line. For example, if we have points like this, and it turns out that this is a line y equals 2x, we can now predict that when the data point is 2 times 2, remember, how do you get y? Y is, equals means is. Y is 2 times x. You multiply 2 times x, you get y. If I tell you this, and this is important, if I tell you what I circled, and please, I didn't circle x. I circled 2x. Let me make that very clear. If I tell you what I circled is 10, then y equals, since y equals what I circled, and I'm telling you what I circled is 10, then y equals 10. If what's in that circle is 50, then y equals 50. Y is equal to whatever 2x is. If I tell you 2x is a million, you should say, oh, y is a million. If I tell you 2x is negative 11/3, you should say, oh, y is a negative 11/3. Y is whatever 2 times x is. And if x is 3, let's not have too many 2's. If x is 3, then we are going to claim that the y value is 6. And it looks like the point when x is 3 was more like 5. So we weren't off by much. Let me blow that up again. Let me blow that up some more. Here is a line y equals 2x. When x is 3, y is going to be 6. 3, 6. Now, it might be that when x was 3 in the real data, that y was 5. Might be that. Like I said, the line is a good approximation. When x is 4, the y value should be 2 times 4 or 8. It might actually be this time that when y was 4, or x was 4, use the same color, when x is 4, y really was 8. You might have a data when x is 5. Our line is going to say that when x is 5, we're going to approximate x with 10. In fact, it might be that our data says when x was 5, that y was 11. Okay, the line's an approximation. What I have in red, these are the actual data points. They cluster around the line. Some are above, some are below, some might be right on the line. Okay. So again, in this section, our objective is to find the equation of a line that does have a linear correlation. Now, just for the record, if you have, let's just deal with quadrant 1, which is in here. If this is quadrant 1 and this is your data point, notice it's all over the place. Well, if I draw this line, half of the points are above and half are below. If I draw this line, half are above, half are below. If I draw this line, half are above, half are below. If I draw any line that crosses, quote, the center of those points, it's going to, one half of the line is going to contain half the points. The other half of the line will contain the other half of the points. There's not one line that fits those points the best. That's why we say there is no linear correlation. Okay, so let's get into doing a linear correlation problem. If you recall in our basic algebra, every line can be written in the form y equal mx plus b. With linear regression, we just write it differently. Y hat is equal to b0 plus b1x, which for the record is the same as b1x plus b0. That's like the m, and that's like the b from above, the m and the b. But again, for us, whether you want to think about what I just said or not, this here is the equation, the regression line. The equation of the regression line. Now, what is B1 and what is B0? Well, B1 is a bit complicated. B1 is n times the summation of xy minus the summation of x times the summation of y divided by the n times the summation of x squared, very similar to the formula for r. N times the summation of x squared minus the summation of x all squared. That is how you find B1. That's how you find that value. And you're going to be given the data, and that's how you find B1. And B0, B sub 0, is going to be the average of y1 minus the b1 that you just calculated on the line above times the average of the x's. Okay, so it's not the friendliest formula, but that's what it is. Let's get a little more space going. So what's in the box, that's the equation, that's the regression line equation, and below it tells you how to get b1 and how to get b0. Y hat and x, they just stay that way. Now, suppose you were given this data. Suppose you had some x's and y's, and you were told that x takes on the values 3, 1, 3, and say 5, and we have the corresponding y values. 5, 8, 6, 4. So now I'm ready to write down the equation. It's y hat equals, and then I'm like, y hat and then equals, and now I'm like, oh my, what's B0? Oh, well, we can't do B0 yet. So you leave a little space plus B1. So first we have to calculate B1. B1 starts off with n. N is 1, 2, 3, 4. N is 4. Now, I have to multiply the n by the summation of x, y. Well, I don't have the products, the sum of x, y's. Well, x's are 3, 1, 3, 5, and y's are 5, 8, 6, and 4. Well, I need to add up x, y's. I multiply those, x and y's, I multiply those x and y's, these, and then these. 38 and 23 is what? 61. So the summation of xy is 61. Okay, 61. Then I see a minus. Then I see the summation of x's. So I add up the x's. 5, 8, 9, 12. The summation of the x's are 12 times the summation of y's. So now I add up the y's. 4, 10, and 13 is 23. Divided by n, which is still 4, times the summation of x squares. X squared. So I have to now square the x's. 3 squared is 9, 1 squared is 1, 3 squared is still 9, and 5 squared is 25. 10 and 25 is 35, and 9 more is 44. That's the sum of the x squares, 44. And then I have to take away the summation of x, which is 12, but then I have to square the 12. 12 squared. This product is 244. This product is actually going to be, I guess 276. 4 times 44 is 176. And minus 144. So the top is negative 32, and the bottom is 32. So B1 is negative 1. Okay, I don't know why okay, B1 is negative 1. All right, so let me just put that here. B1 is negative 1. Okay, now let me find B0. I lied. I'm not going to write the formula down there. I'm going to find B0. B0 is the average of the y's. Y hat is the average of the y's. Well, so you add up the y's, you get 23, and then you divide by how many there are. Minus B1, which is negative 1, times x hat. Well, you add up the x's, you get 12 divided by 4. Well, you have 23 over 4 plus 12 over 4. Because if you take away a negative, it becomes plus. So B0 is 35 over 4. Okay. B0 is 35 over 4. I'm going to erase 90% of the bottom half. And now we're going to write up our answer and do it all over again with another problem. So y hat is equal to B0, which is 35 over 4, plus a negative 1 times x, which is 35 over 4 minus 1x. And you don't need to even write the 1. You want to write the 1, write the 1. Either that equation or y hat is 35 over 4 minus x. If you were in my class, I would accept I as a one of them. Now, let's see what I'm saying about this being a good approximation. I know, suppose when x is 2, then we claim that the y value should be 35 over 4 minus 2. But I'm going to write the 2 as 8 over 4 because in subtraction, it's just so much easier to have the same denominator. And 8 over 4 is 2. So you get 27 over 4, which is 4 1/4. Okay, but I don't buy that for some reason. It's 6 3/4. That's what you would approximate the y value to be if x were 2. This is if x is 2. Let's see how good of a job we did. Let's see when x is 5 what our line tells us. Y is 35 over 4 minus 5. But I'd love to write a 5 with a 4 in the bottom. Just remember, 4 times 5, whatever that is, that has to be the numerator. It's 20 over 4. That's also 5. So you subtract the numerators. 35 minus 20 is 15. You keep the common denominator. And you get 3 3/4, which is actually not so bad. It's about 4. And where did I get 4 from? We were told that when x is 5, y should be 4. And I didn't want to plug in x equals 3, because when x is 3, we got two different answers. We got 5 and 6. Okay, so this equation, the line in the bottom left corner, it should be a reasonably good approximation to estimate for the data. The closer r is to 1 or -1, the better the correlation is, the better this line will approximate the data. So in other words, if we did this for the heights of mothers and their respective daughters, we can now, if it's a really, really good correlation, if r was close to 1, then we could approximate your height the day you were born, even before you're born. We'll just say, how tall is your mother? Okay, maybe every daughter is exactly 1 inch smaller than their mother. Okay, that would be a disaster because we'd have an awful lot of short people. And why is that true? Because if some mother is 7 foot tall, which is very tall, the daughter will be 7 feet. Their daughter will be 6 feet, 11 inches. And this person's daughter will be, if they had a daughter, will be 6 feet, 10 inches. And this person, if she were to have a daughter, that daughter will be 6 feet, 9 inches. Eventually, you're going to get, it's going to go to 0. It's going to go to 0. There are really, really short people out there. So one would wonder if there really is a correlation. So let's look at some other data. Suppose you have two variables, x and y. The meaning between them isn't going to help us understand this anymore. But there must be some meaning. You can make up your own scenario. X is how many hours you watch TV. Y is your grade. Okay, so now we want B1 and B0. Remember that B0 is y average minus B1 times x average. That's an easy one. But B1 is an unfriendly one. It's n times the summation of xy minus the summation of x, and multiply that by the summation of y, and then divide that by n times the summation of x squared, and then don't forget to take the summation of x squared away from that. Well, first thing I see is n. Well, we should know by now that we're not going to get away without making this table. 1, 1, 2, 5, 3, 0, 2, 2, 3, 5. So I see that I have to add up xy's. So I need a heading that says xy. And I also know by now I have to add up the x's. 3, 8, 10, 11, 12. I have to add up the y's. 5, 8, 10, 12 as well. Now I'm going to add up xy's. You multiply x by y. 1 times 0 is 0, 1 times 2 is 2, 5 times 3, 5 times 3. 30, 4, 36. 36. Oh, let me put the answer down here. So it's n, which is 1, 2, 3, 4, 5, times the summation of xy, which we just computed to be 36, minus the summation of x, which is 12, the summation of y, which is also 12. I divide this by n, which is 5, times the summation of x squared. Okay, so I need x squares. I need to have a heading that says x squared, and then I need to add it up. So I square the x's. 1 squared, 1 squared, 2 squared, 5 squared, 3 squared. Love tens. 10, 14, 15, and 25. I didn't make a mistake. It's 40. So the summation of x squared is 40 minus the summation of x, which is 12 squared. So it's 12 squared. 5 times 36 is 150, is 180. Minus 12 times 12 is 144. 5 times 40 is 200. 12 squared is 144. So the top is going to be 36, and the bottom is going to be 20 more. It's going to be 56. And 4 goes into each of these numbers. 4 goes into the top 9 times, and it goes into the bottom 14 times. Okay, so it's 9 over 14. Yeah, I'm happy with that. So that is B1. So now, what is B0? It's y hat. Well, the y's added up. How do you find y hat? You add up all the y's and you divide by how many there are. 5 of them. Minus B1, which is 9 over 14 times x hat. You add up the x's, you divide by 5. Okay, let's get a common denominator here, but first we reduce. 2 goes into both of these numbers, 6 times and 7 times. So you have 12 over 5 minus 9 times 6, 54, over 7 fives, which is 35. So the LCM between 5 and 35 is 35. Multiply the top and the bottom by the same number, 7. Why? Not because 7 times 8 is 7 times 12, is 84, but rather because 7 times 5 is 35. I had to multiply the 5 by 7 to get 35. So I multiply top and bottom by 35. Why did I want 35? Because the other fraction is over 35. In subtraction, if the bottoms are the same, keep it, subtract the tops. 84 minus 54 is 30. And 5 goes into 30 and 35. 5 goes into 36 times and into 35 7 times. So this is B1 and this is B0. Okay, let me erase a good part of this so I can write down the equation the linear regression equation. Just remember that y hat is equal to b sub 0 plus b1x. Y hat is equal to b0. I'm going to use these numbers over here. b0 is 6 over 7 plus b1, 9 over 14x. And here is the line, the prediction line. It can predict things. It can predict the y value when you plug in an x value. How good of a prediction will it be? Well, go back to the data and calculate r. If in absolute value r is close to 1, that is, r is close to -1 or r is close to +1, and then this line will be really good. In fact, if it was a perfect correlation, this should be the equation of the line. Okay, that completes this section. In fact, it even completes the video. I hope you enjoyed it. Thank you.